More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Good day, everyone. Welcome back to Mathnasium Schoolhouse. As always, I am Sandra. I will be your instructor for today. Very, very happy to be here all with you. As I always encourage all of you to do, if you are a student joining us, I would love to know who it is that we have and, of course, what grade level you are in. Maybe even tell me what interests you, what brings you here to learn about graphing points and lines today. I'd love to see that. There we go. I have my first student, Madhav. Very nice. Perfect. Today, as the title says, we will be graphing, and so if you by any chance in your home have some grid paper that you might want to pull up, ask a parent or anybody in the house to bring it to you. That would be strongly encouraged, but no need. You can always follow along with our exercises regardless, even if you don't have it. Welcome, Andy Srikar. I hope I pronounced that correctly. All right. Wonderful. Zoya, perfect. Love to see the names. Okay, well, we have quite a few exercises that I want to get through today, a wide variety of them, because the cool thing about graphing is that, as you'll see, you can do so much with it. We can have a lot of fun, and that's, of course, what we always try to do, I should say we always do at our Mathnasium Schoolhouse lessons. So today, I want to take a fun take on this by starting off with a little bit of a game. So I'm going to present to you my whiteboard here, and I'm going to place this right in front of the camera. This is what we're going to use as our game board for today. Let's hope that doesn't curl up too much. And what I'd like for you to do as an introduction to graphing for today, I see some excitement already, is tell me, so on my version of this grid, I have two butterflies located on here. You guys don't see it right now because I want you to guess where these butterflies are located. Now, the way that you're going to do that, I'll explain, is you can see on this grid here, there are some numbers at the top, there are some letters on the side here, and in fact, it goes from the bottom to the top, A, B, C, D, E, and from the left to the right, we have 1, 2, 3, 4, 5. So the way that you're going to guess where my butterflies lie, and again, just leave in the comments what your guesses are, is to tell me the letter, which will tell me which row they're in, and the number, which will tell me what column they're in. So go ahead and share some ideas, and I will place maybe, let's see, I will use, just because I have a red butterfly and a blue butterfly, I'm going to use a green marker to check off if that's in fact true, that my butterfly is one of these cells, and then I'll use a black just to cross it off that that's incorrect. So go ahead and share some ideas of where you think my butterflies are located in these boxes. And I'll show you them in just a second. Go ahead and guess. Maybe you want to guess, and I'll give you one. B5. And I can tell you, for example, that is not where one of my butterflies lies. So I'll just put an X there. Okay. Oh, I got some coming in. C5. I need to double check if that's right. C5 I do not have. Then I see E2. E2 is actually correct. E2 is my red butterfly. Very nice. Oh goodness, D4, C3, D4, C3 are both incorrect. Oh, I'm sorry, D3 is also incorrect. D4 and C3. What else do I see? B5 is incorrect, I got that. A1. Oh, I'm sorry. I'm making a mistake. I'll tell you also that E1 is incorrect too. Let's see what else there is. And let's see if you guys are getting my second one, which I need to remember is not on the list yet. Oh, it is. I see. Do I see it? Yes, I do. So someone said B4, and that is correct. So those are where my two butterflies lie. Okay? And I could have added more, but those are where my two butterflies were, right? So I have, let's use a red here. So I have E is the row for my red butterfly, and the column is 2. So that one was correct. We had that. And someone said B4, which maybe I'll use my blue, is correct for my blue butterfly. Row B column 4. There we go. Perfect. So this is, you'll see a nice introduction to graphing, and for some of you, you'll see that this relates to a game you might already know. And if you want to guess that name, go ahead. I'll reveal it in just a second. But what you were doing here was trying to guess, of course, the position of my butterflies, right? All I gave you was a blank grid, and I asked you to describe to me, just through writing out your guesses in the comments, where you think my butterflies are located. And so your best way to do that for me was to explain the position, which was exactly as I said, what row and what column, using the letters and the numbers, just to help us out a little bit more. Okay? So for some of you, hopefully you're saying, oh my goodness, this reminds me of a game called Battleship, a very popular game, which is exactly true. I was thinking, how can we put some Mathnasium spin on it to somehow virtually play Battleship together. So there you go, and if you want to go ahead and try that out, yes, at home with some of your siblings or your friends, you are encouraged to do so. Okay? So as I said, the cool thing about this game, the reason I want to use is that prepares you for this math skill of graphing, and other questions that can arise from playing something like this is maybe I can ask you, well, how can the red butterfly find its way to the blue butterfly? Take a few seconds to think about that, share if you have the answer. How can the red butterfly get to the blue butterfly? They're friends, they want to be together. How can you explain to me, or explain to the red butterfly, how to get to the blue one? Other than saying that it can fly. How about you explain what path it can take to get there? What could we say? Hello to Anna, Suzanne. What could we say? How does the red butterfly potentially get to the blue butterfly? What path could it take? Okay. So in that, I'm asking, can it go left or right? Oh, there we go. I see an answer. I'll read that out in just a second. Left or right, up or down, what could it go? If it just wants to go in straight paths. So I see go down to B2. Okay, go down to B2 first. And then I'm assuming you want to go right to B4. Is that right? Okay, there we go. Someone said up to E4. I'm going to just slightly change that answer and say let's go right to E4. We'll stick with left and right first, but the other way works perfectly fine. E4, and then we can say 2 units to the right. We'll be using some of this language a lot more. So 2 units going to the right, and then 3 units going down, which is exactly what you guys are saying. Perfect. So I'll just write down 3 units. Only because, again, we're going to be using this language more. So let's get familiar with it. So we can go right and then down, and that's exactly what the the red butterfly could do to get to its friends. So as I said, today we'll be looking at graphing. You might also hear me also refer to this as plotting, which just means plotting points on a graph. So we'll look at what the graph looks like, or a grid looks like for our purposes today. And you can do that to form some shape, and just as we saw, to even describe the positions of these points. So we'll be doing the 2 of them together, and we'll look at different shapes and what we can do with those. Okay. So let me remove this, and I'll pull up a grid in just 1 second. Let's start with something very basic. So I said we're going to be plotting points today, right? So a point will just be represented by a dot, just like this, right? So a point will be represented as a dot. We plot points on a grid, which is what I'm going to pull up right here. Let me just erase this, right? We plot points on a grid. We'll explain what each of these components mean in just 1 second. And this is going to be called for us, and what it's called in math is a coordinate plane, okay? This is just one part of it. We'll look at the bigger picture in a few minutes. With a few more exercises. So as I said, let's review the components. If we're going to be working with this, let's understand or review for some of you what we're working with. All right. So there are 2 axes, and maybe I'll use a red for this, just to make it stand out against the black that we already have on this page here. So you can already see the coordinate plane displayed here. A couple of things I want to point out are that there are 2 axes that, of course, divide. Great, I love these too. Thanks for sharing that. That divide the coordinate plane, right? And these, as you saw in the game that we just played, help us plot our points because they help us explain the position of these points, right? Which then multiple points can form shapes and so on. So they're extremely useful to understand, okay? The vertical axes, which if you understand the word vertical is going up and down, right? In this case, it's going continuously up. The vertical axis is also known as the y-axis, and you'll see that determined with just a y, right, by this arrow here. We'll quickly talk about the arrow in just 1 second. And as I said, it tells us how much we're moving up by, we're moving our point up or down by when it comes to translating a point. And we'll see that over and over again today. And the other one, which is this axis here, it's referred to as our horizontal axis or our x-axis. We display that, we show that with the x, just to remember, okay? So if I forget to do that on some of mine, you guys are responsible for helping me remember that that's what I should do. Always make sure that you label it for yourself. It really helps you to remember how to plot your points, right? So this one tells you again, up or down. This one will tell you, I don't know if I said that just yet, left or right. So it's just the other direction, okay? Those are the two axes on our plane. The next thing I want you to know here is that the axes meet at a point, and this point here is known as the origin. If you already knew that, go ahead and share. Maybe even tell me what point the origin represents. Okay, so this is where the two axes meet. It's called the origin. I'll just write that in for right now. I won't always label it. But you'll often see it labeled not with the word, but just with a big O or maybe even a 0 here. And we'll talk about that too. Okay, each space on our axes today, and depending on the variety of exercises that are out there, they might be represented by different amounts. For our purposes today in all of our exercises, each space represents 1 unit. And so my markers are maybe too thick to show this, but I can show a few numbers. So when we move up or down, each space is indicated by 1 unit. So I have 1, 2, 3 spaces, 4, 5, 6, 7, 8, 9, 10, and I apologize if the marker is too thick to see this properly, but it is just going up by 1s. And then same, I can explain my, or describe my x-axis. It's going left and it's going right, increasing by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Oftentimes when you do these problems, maybe in school or if you have some work at home, you'll have the numbers already there, so you won't have to do this every time. I just wanted to show you how it goes from a plain grid to a filled-in grid. So this is what we have to understand about our coordinate planes when we work with them. And as I said before, these arrows exist because, of course, our axes go on forever, much like our numbers go on forever. So although I stopped counting at 10, because I don't want to spend the time writing out all the numbers, once I got to 20 or however many spaces I have here, those numbers would continue on forever. All right, so let's keep all of that in mind and let's kind of do some exercises on here. Because now that we understand the components of the grid, we can do so much. All right, it's not that thick, perfect, good. As long as you guys can see the numbers. So we already see that the axes allow us to move up or down or left or right, which means naturally our points need to be described by this movement. Again, we see that from the game that we played. And we need to describe this movement from one specific point. And that is why the origin is so important to us. We'll always describe our movement from the origin from this point here. Okay? So starting from the origin, the steps are always going to be the same as follows, which is to first go right on the x-axis, okay, however many units we are told to move, and then go up on the y-axis for every single point. So I'll repeat that throughout our exercises. Let's keep that in mind for today. Okay, you guys are making fun of my numbers, which is all good. I know it's difficult to see. Which means that all points, and I'll write that just up here, all points are represented by their movement x and y. So that's how we will represent all of our points. Okay, yes, I'll give you a problem right now. So let's say I want to plot the point 4, 5. Let me write that here. You guys can help me out with that. How can we do that? How can I plot the point 4 and 5? My x is equal to 4, and my y is equal to 5. You can see that. Okay. Well, let's follow the steps that I just laid out for us. Well, First, I always need to start at the origin, so that's exactly where I'm going to start with my marker. Then I need to move right. By how much? Well, the first part of my point tells me exactly that, which we're going to call the x-coordinate. So the x-coordinate tells me it is a 4, which means I need to move 4 units to the right. So let's try to do that. 1, 2, oh, you guys can't see that. 1, 2, 3, 4. So with an arrow, I'm just going to show that here. I moved 4 to the right. And the next step that I laid out for us was I needed to move up. By how much? Well, the same thing. The second part of my point tells me exactly that. We're going to call this the y-coordinate from now on. And that y-coordinate is, of course, a 5. And so that tells me that I need to move 5 units up. So 5 units up from where I just ended off would be, let's see if you can see this properly, 1, 2, 3, 4, 5. So I'll draw that in. All right. So this is where I end off. I'm just using the arrows to help you guys see the direction. Normally you wouldn't have to use them. You could just go ahead and, perfect. Oh, someone laid out the steps exactly as I just explained. Move right 4 times, then from there move up 5 times. Beautiful. Thank you for sharing that. Okay, which means we have now plotted our point. I will use a green for that. It is right over here, and I can label it with its ordered pair. All right, there we go. So let me give you another problem. So let's say this time I want to explain to you where your point will end up, okay? And you have to tell me the coordinates. So I will write that here, and while I'm working on that, I'll erase this. Or sorry, while you guys are working on that, I'll erase this. So from the origin, I want you to go 3 units right and 4 units up. So tell me what the point is, what the coordinates are of this point while I just prepare our board here. Okay. Just fill in those numbers again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So, oh, there we go. I see an answer and I like it. So let's see. I'm going to try not to use my arrows this time. Let's just see how we can do this just by following these directions. So if I need to start off from the origin, I need to go 3 units right. So I'm going to do that. And again, I want you guys to see what I'm doing here. 1, 2, 3. Great. And then from there, I need to go 4 units up. Great. I'm going to do that. 1, 2, 3, 4, which means my point ends off there. I didn't have to graph it, as you guys maybe didn't even have to do. If you don't have the grid paper in front of you, you might have just followed the directions and known, okay, if I know how much I'm going right by and how much I'm going up by, based on the exercise we just did before, that means my x coordinate is a 3 and my y coordinate is a 4. If you wanted to graph it, plot the point the way that we did here, well, then you can also read it here. My x coordinate for this point is a 3, and my y coordinate here is a 4. And if I just include maybe some dotted lines for you to see, you can see that's how we got to the name, the coordinates here. So again, that is just 3, 4. Wonderful. We're all on the same page here when it comes to this grid. So let's try maybe a little bit more. So let's say that a point is already plotted on a coordinate plane. How do we find the name of the point, or in other words, find the coordinates of the plotted point? Okay, so to find the x-coordinate of a point on the plane, we know, as we just saw, to count how many units right the point is from the origin. All right, and to find the y-coordinate, we count how many units above the point it is from the x-axis. So for example, I want you to tell me, what are the coordinates of this plotted point? So I am going to plot a point. Don't mind the circled 3 here. Just erase that. Fill my numbers back in so you can use them if needed. Okay, so I'm going to plot a point, and I'd love for you to tell me what the coordinates are. All right, so I want to plot the point right here. You guys are being funny with your infinity symbols. So, please tell me, what are the coordinates of this plotted point that I have here, this green one right here? Okay. So following the steps from before, I need to find out how many units I've moved right from the origin, and then how many units have I moved up from the x-axis, right? So let's count that. Well, I have moved, and if I need to help myself out, I can draw in these dotted lines. I have moved 1, 2, 3, 4, 5 units to the right. And then from the x-axis, let me actually write that down for myself to remember. From the x-axis, I've moved 1, 2, 3 units up. There we go. Right? Knowing how much I moved right and up, I know my point, my coordinates, 5, 3. Wonderful. Great. You guys are getting it. Wonderful. All right. Now, however, and I just want to address just a precaution here, the next little bit we'll be dealing with negative numbers. If you haven't seen them before, don't be scared. It's just something that you'll learn later on in your math studies, but it is still something that you can easily follow along with here. So definitely stay tuned for the next little bit, because of course this is just a smaller picture of a bigger coordinate plane, right? So far we've been looking at just right and up movements, but I indicated before that you can also go up and down, right or left. And so what happens if I go left beyond the origin, right? There's still I can still perform that movement, I just need the bigger picture. So let me maybe pull up this grid here, right? So the cool thing about the coordinate plane is that it actually extends in all directions, right? We were just looking at a smaller picture of it. It actually extends in all directions, right? Some of you might have heard this referred to as different quadrants. We don't have to use that language today, but that is of course true. So as I said before, the coordinates of a point tell us where to move up or down, left or right. So to plot points on a full coordinate plane, we follow the exact same steps as before. We start at the origin, right? The point 0, 0, this guy here. Oh, my red isn't working for me today. That's fine. We start at the origin. It's right over there, right in the middle, exactly as we explained it before, where the two axes intersect, right? Where they meet each other. If you're not familiar with the intersect language, no problem. And then we move left or right from there, very much like we were doing before, even though we were just moving right. And then we go up or down on the y-axis. Okay? Again, we'll still be left with a point whose coordinates are x and y. So same steps. As I said before, we are dealing with some negative numbers. So we'll see how that works. So let's try this one. So from the origin, I'll remove that here. Now I don't have numbers on here. Typically we want to do that. I will though indicate for us that there is an x-axis here and a y-axis, because this is just a little bit too small and I don't want you guys to feel confused with a bunch of numbers on here. I won't necessarily indicate them, but we are still working with spacings of 1 unit, okay? Typically when you have these typed out and printed, they're a lot easier to read as well. So let's try this one. From the origin, I would love for you to go 2 units right, and then 3 units down. What are the coordinates here? Starting at the origin, 2 units right and 3 units down. What are the coordinates of our new point? Okay. So we did a lot of these before on just that first quadrant. So let's see if I move here 2 units to the right. I'll use an arrow to show it. And then I want to move 3 units down from the x-axis. Well, then I do that. 1, 2, 3. You guys can see that right there. So if I remove my arrows, keep in mind where my point is. I'll remove my arrows. Okay. And so I have my point here, and now I need to determine what the coordinates are. Well, let's see. I know that my x value, my x coordinate here, is a 2. Very similar to what we had before. So I'll write that here. but my y-coordinate here is not a positive 3. Because I went down, I went below the x-axis, it's actually in the negatives. So this would be -1 here, this would be -2, and this would be -3. All right, so I will just write down -3 here, which means that we have a -3 as our y-coordinate. There we go, right? So what if then I asked you to plot a certain point? What if I asked you to plot very similar point? -2 is my x-coordinate, and 3 is my y-coordinate. I'll erase this. Okay. How do I plot this? Well, let's follow our same directions. So this is telling me here to not move right, but the negative here is actually telling me to go left, the opposite direction. So I'm actually going to move 2 units to the left. And because there's no symbol here, we know that that is just being represented by a positive. And so this is just moving up. Right? So we're gonna start at the origin as always. So if I start at the origin, make sure you guys can see that. Starting at the origin, I'm going to move left or right first. We know that we have to move left. 2 units to the left means 1, 2, okay? And then 3 units up from there, I go 1, 2, 3, which means this is now my new point. And let's just call this point M. All right, there we go. And let's say I give you one more exercise before we have a little bit of fun with this. Let's say that I give you a point A. Let's say I give you this point here. Tell me what the coordinates are of point A. So I've drawn a point, I've named it A, I've labeled it point A. Tell me what the coordinates are here. I'll give you maybe a minute for this. Interesting question you guys are asking. So why X and Y, not A and B? It's just the way that we determined it. Sometimes math can be funny. All right, so what are the coordinates of point A? Let's see if anyone can help me out here. Think, how many units have I moved left or right from the origin? And then how many units have I moved up or down from the x-axis? Okay. So if you understand where the origin is, oh, I see a -2 popping up. Yeah, exactly. So I'm assuming, oh, and I see the answer there. Okay, great. So I'm assuming only a -2 is given for a few answers because the 0 maybe threw you off. And where's that 0 coming from? Well, let's see. Sandra just asked me how many units did I move left or right from the origin? Well, it looks like I didn't move anywhere. I didn't move, beyond the 0 in the right direction or the left direction. I actually stayed there. All that I did was I went down 2 units, which is exactly true, right? Which is what your -2 is showing me. And the way that we can indicate that is still writing in that 0 for the x-coordinate, which tells me 0, I did not move any units left or right. I still need to have something there for my x-coordinate. But for my y, you guys are already telling me I've moved 2 units down. Sorry that you guys can't see that. 2 units down. And that's it. Okay. Perfect. So now that we know how to plot points on a coordinate grid, I like to joke that the world is in our hands. Obviously not really, but definitely in the world of graphing, we can now do so much, right? We can do so much on the grid here. For example, let's say you have a favorite shape, a favorite object, a favorite animal. You can graph it in some creative way and name it by its points, right? Just another way to explain it. You can have a lot of fun with this, especially if you're an artistic, creative person, which I definitely have that side to me. It could be really, really fun. Right, so let's explore this a little bit more. Let's say that I give you 3 points. I'm going to name them here. And I ask you to plot them. So if you have a grid, go ahead and do that. All right, so let me just show that here. The 3 points that I am asking you to plot on your coordinate plane are, let's see, 2, 3, and -1, 6, and 5, 7. Okay. Go ahead and plot those and connect them with straight lines once you do that. You'll see some sort of shape form, and I'd love for you to just tell me in the comments what shape is formed if you were to connect these points together with straight lines. Right? So I'm going to start off by plotting them the exact same way we've done before. I'm not going to give anything away in terms of the shape, but you'll slowly see it forming. But if you guys can do that ahead of me, that'd make me very, very happy. So first point here, which I can name point A, this will be point B, and this will be point C, just to help me out. Tells me that from the origin, I go 2 units to the right, great, and 3 units up, 1, 2, 3. That's my point A. And then I have a second point B, which tells me I have to move 1 unit to the left of the origin. Okay, so from the origin, I move 1 unit left and 6 units up. 1, 2, 3, 4, 5, 6. I've got point B right there. Okay, I don't see the answer just yet. All right, and then I have point C, which is 5 units to the right of the origin. 1, 2, 3, 4, 5, and 7 units up from the x-axis. 1, 2, 3, 4, 5, 6, 7. So that's my point C. Okay. And then I asked you to connect them with straight lines. I'm just going to use a straight edge to do that. I will do that maybe with green. Okay. Just connect them just like that. See what I'm doing there. What shape is formed? Of course, it's a triangle, right? A shape with 3 sides and 3 vertices is our triangle. All right. Now that we know that, I would love for you to keep that on your grid and plot these new points. So I'm going to switch these up and ask you to plot 3, 5. And let's just call these D, E, F now. So I'll write that in just a second. 0, 8, and 6, 9. Let's go ahead and do that. Okay. And I would love for you to again connect them and tell me what you notice about your original shape and this new shape. Go ahead and try that out. So let me maybe use a black here to do it. So again, I'm just going to speed us up a little bit. We know how to plot these points, so let me go ahead and do that. D will be located right here. Oh, my markers are not treating me well this time. Let's see, D is here, E is 4, 5, 6, 7, 8. And F is at 6, 9. I have to move 6 units to the right and 9 up. So let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I form that together, I should use my straight edge. I just don't want to by accident erase what I have here. So let me just connect them just like this. Pretty straight lines if I do say so myself. Now, what do you notice about these two? Okay, I still have the same shape. It's exactly the same triangle, but it's been, and if you've heard this language before, great. You can practice with it here and tell me, maybe describe the transformation. So what I've actually done here is translated my original shape, which I have outlined in the green, to my new image, which is the same triangle. It's just been moved up and it looks like to the right. And to find out and describe that translation, I can look at one point here. So let's say I wanted to look at the bottommost point of my triangle. Where did it move to? Well, it looks like it moved to D. So point A moved to D. By how much? It looks like I went to the right by 1, right? If you can see that there, to the right by 1 and 2 units up. And so my translation was, what did I say? 2 units right and 1 up, 1 unit up. Okay? So already what we can do when we know how to plot points, we can create shapes. That's one thing we just saw. We can create shapes by connecting those points together. Then we can do stuff with those shapes. We can move them around on our coordinate plane and still describe those movements, right? By just telling us, take your original points, move them according to these directions, connect those new points, and see what has happened from the original. Okay? Let's play around with that again. So let's say that I give you 4 points, A, B, C, D, and they are as follows. They are 1, 1, 2, 3, negative 3 and 3, and negative 4, 1. Go ahead and plot those and tell me what shape is formed. Hopefully you can see that while I prepare our grid for us. Okay? When you connect them with straight lines, what shape is formed? Okay. And I will go ahead and fill that in. Blank grid now. So I have, what did I say? I have point A is at 1, 1. There we go. That is point A. Then I have point B at x is equal to 2 and B is 3, so just over here. Then I have C. I have to move 3 units to the left from the origin. 1, 2, 1, 2, 3. And I need to move 3 units up. 1, 2, 3. And then I have point D, which tells me to move 4 units to the left and 1 unit up from the x-axis. So 1, 2, 3, 4, and 1 unit up. If I connect that, what shape is formed? Again, I should use my straight edge, but I don't want to risk erasing what I just drew. So I'm going to freehand it. What shape is that? Do I see the answer? You can see it's a 4-sided shape, which I'm so tempted to call a rectangle, but it's actually more like a squashed rectangle. It is a parallelogram. Okay? So again, we can draw different types of shapes. We just did. And now, if I tell you new points, you can observe what I did to get from this original parallelogram to its transformed parallelogram. So let's say that I asked you to plot these points. So the new points are 1 at negative 1, 2, negative 3, negative 3, negative 3, and negative 4, negative 1. Okay, and we'll call this E, F, G, H. Okay. All right, polygon I'm seeing, very cool. All right. So what happens if I plot now these points on the same grid? What can you observe as the relationship between this parallelogram and the new one that's formed? Okay. So let's see. I'm going to use my blue just to distinguish between the two. I'm going to go ahead and plot these based on what we learned earlier. 1 and negative 1, 1 unit to the right, 1 unit down is my point E. 2 units to the right, 3 units down, great, is my point F. 3 units to the left, 3 units down. 3 units to the left, 1, 2, 3, 3 units down is my point G. And 4 units to the left, 1 unit down. 1, 2, 3, 4. I get this. I'll connect those, again, just freehand the way I'm doing. What do you notice about these two? And if you've seen transformations before, you might know the official name of this. And if you haven't, you can still explain this to me, right? It looks like what happened from the first parallelogram to the second looks like I just flipped it. And the official name that we call that in math when we study this is a reflection. We have to explain where did it reflect, where did it flip? Well, you can see it was all along this x-axis, right? I took this, and if I held a mirror, right when I said it, I saw the word pop up. If I had a mirror, this parallelogram would be flipped right in that mirror, and that's how I get my new one. Okay, so just some cool things here. If you've heard of dilations, I invite you to explore those too, which is again just enlarging or shrinking your shapes. That's another cool thing that you can do with graphing. So let's just take this a little bit further and we'll end off for today. So this is more of an extension. Again, I welcome you to try these out. Okay, and we'll explore what it means to graph a line. How can we do that? Okay, so let me remove this, clear this one off, which isn't too nice to me, but we did it. And actually, you know what? I'm going to pull out a template that we'll use in just a second, okay? But we're going to explore what it means to graph a line. So some of you might be comfortable doing that with a line segment, right? So let's say I give you 2 points. Let's say I gave you 4, -3, 4, -3, and I don't know, let's say I gave you 0, 3, right? We could connect those two and we have a line segment, okay? A line, the difference between the two is that a line would just continue on forever, okay? Just to simplify it a lot for our purpose today. So one way to graph an equation of a line, so let's say we were given an equation, which again, if you haven't seen it before, don't worry, we'll simplify it a lot for the purpose of today, is to plot the points. So when we know how to plot points, like I said, we can do so much. We can even work with equations even before we've even seen it in a classroom or anywhere officially. That's a really cool thing about math. You don't have to wait until those, because so much of what we learn connects to each other so beautifully in so many different ways. So let's go back to equation of a line. Given an equation, which I'll give you in just a second, we're going to work with very, very basic one. I need to remember that my black marker doesn't work anymore. Let's say I have an equation like this. Again, don't be scared if you haven't seen this before. It's not essential for this right now. But we can work with this and find points that satisfy this equation, then simply plot those points, connect them much like we were doing to form our line. So that's what we're going to do. I will remove this. We don't need it. So let's say we're going to use this template here. We want to work with that, right? I'm going to use this here. As I said, we want to graph a line that is represented by this equation, okay? So we can explain this line with this equation or with a few points, which we'll do in just a second. So that's what we're going to have right here. I don't want to write on the black, you won't see that, so I'll just write it above just there in the table. We're going to use a table to help us out. It's the best way to plot and graph a line if we're not comfortable reading this equation right now, which I don't expect you to be. So we can pick any value we want to substitute for our x right here. I'll explain that more in just a second. And for the purpose of today, just to stick with very small numbers, I've chosen 0, 1, and 2. So those are the x values that we'll work with, right? To then find some points that satisfy our equation and graph them on this grid here, okay? Once we then find the value of y, after knowing our x that we're substituting in, oh, that's an interesting comment. I do this when I do coding. Oh, I love that relation. Very cool. Nice connection that you made there. Thank you for sharing that. So once we get a value for y, we'll then have an ordered pair, as we've already been seeing. And it'll become a lot easier because then we just go back to exactly what we've been doing, which is just plotting these points and seeing what line is formed. So really simplifying this here, right? So let's do that a bit. So let's say I want to use my x is equal to 0. What does my y equal? Well, without knowing too much about solving for equations, if I have a 0 here instead of an x, what is 0 plus 1? Very simple, it's just 1, and so my y would be equal to 1. Okay, I'm going to erase that. Next time, draw it above Let's say then my x is equal to 1. 1 plus 1 is my y. 2. Let's say my x is equal to 2. 2 plus 1 is my y. 3. Okay. So here's where I could have written actually 0 plus 1 and 1 plus 1 and so on. Right? And so we got 1, 2, 3, which means my points that I can then plot on here are x and y, 0 and 1, x and y, 1 and 2, x and y, 2 and 3. And then I can use this coordinate plane here to plot those points, connect them with the straight edge, and we'll be done. It's as simple as that. There's no need to understand this equation right now. Okay, so let me just go ahead and plot them the same way we've been doing all day today. 0 units from the origin when it comes to movement left or right, but 1 unit up from the x-axis gives me 0.01 here. 1 and 2 tells me 1 unit to the right, 2 units up. 2 and 3 tells me 2 units to the right and 3 units up. If I just connect those with a straight edge, and as I said, a line just continues forever, I have enough information to know this is what my line looks like. And as I said with the axes, because it continues on forever, we'll indicate those two ends with an arrow. Just some cool facts about a line if you didn't know them already. Okay. And as you can see, for a line, I didn't need all 3 points. Really, all that I needed were 2 points. Let's say I didn't have this middle one, I'd still be able to connect those 2 points and show that they go on, extend forever. So really, the way that I like to think of it as, I need 2 points because one of them will tell me where I'm going to start, and the other one will tell me the direction. So just another very cool thing about lines as you explore them more and more in your math studies. Okay? I can give you yet another one if I told you to find y is equal to x minus 2. We're not going to do that just yet. I'll save that for your packet, which you'll have shared with you right after today's lesson. But you can take another equation and just follow along the same way in the table and then go ahead and graph it. Okay? Other cool shapes to observe would be circles. Try to think, how much information do I need? How much information do I need to graph a circle? I just heard someone say, or I saw someone say that this is scary. I promise you it's not. With practice, you'll find that you know so much more in math than you ever thought you did. Okay? So I challenge you to think about, how much information do I need to graph a circle, right? We're obviously not working with straight lines, we're working with curved lines. So go ahead, or curves I should say, go ahead and see how much information do I need for that. Go ahead and explore actually a lot of shapes. One cool game that you can play just before I leave for today is, and I thought of this just as I was preparing for this lesson, is let's say I, just as an artsy person, I want to draw a figure on a grid, right? Let's say I want to draw Mickey Mouse. The only thing to keep in mind is use straight lines for the purpose of this game. It just makes it that much easier. Let's say I want to draw Mickey Mouse on a coordinate plane, and I indicate all of the endpoints of my Mickey Mouse with points, literally coordinates, right? Once I'm done that, I can challenge my sister, my friend, anyone. You can even do this virtually through a video call, and slowly start to tell them different points on your drawing, and they have to start to guess what these points form together. You can make it super easy by telling them in order, right? If they're in the order that they're connected, which would be that much easier because as they get more points, the picture starts to show itself. Or challenge your partner and just create such a random order in the information you relay to them so that it just takes them that much longer to figure it out. You can do so much with this, so much with graphing. I hope that's a key takeaway for you guys all today. I hope that you explore this more. As always, practice and extend what we've learned today through the information, the packet that will be shared with you after today. I love having you guys with me. Thank you always for sharing. Oh, you are going on the adventure with me. I love that. That is such a beautiful way to put it. Thank you for sharing that. Yes, I hope that you guys continue your adventure. And I'll see you all next time. I really enjoy these lessons with you. I hope you do too. Have a great day, everybody.
It's It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.